Here's the answers to the free response quiz on atomic structure. This is where you're going to find the calculations. There are two little equations that are plug and chug, and there are a couple constants that are in the equation packet. We have a diagram that represents the photoelectric effect for a metal. When the metal's surface is exposed to light with increasing frequency and energy of photons, electrons first begin to be ejected from the metal when the energy applied is equivalent to 198 kilojoules per mole of photons. I want to change that to units of joules per photon. That's part A. Calculate the energy per photon in units of joules. So it's just a little dimensional analysis, right? I've got my 198 kilojoules per mole. I can choose to fix either the mole or the joule kilojoules first. I went with the joules. So I said, all right, let's cancel kilojoules, switch it to joules. That's one of the units that I want. I want joules per photon, not per mole of photons. So now, like kilojoules per mole, the mole is in the denominator. So if I want to get rid of it, I need to put it in the numerator. And so then I put moles on the top per photon. There are 6.022 times 10 to the 23rd particles of anything in a mole. And so here we're talking about a mole of photons. Then just plug it in your calculator. But if you're getting funky numbers, if you're like, whoa, I have that set up right, and my answer is not even close to the correct answer, you might just have to watch how you're entering it in your calculator. So I would suggest, if you're really obsessed with the caret key, like if you want to enter this as 6.022 times 10 caret 23, then put this in parentheses. Otherwise, it just might not be recognizing that this is one quantity. And instead, it'll like take your 198 times 1,000, divide that by 6.022, and then it'll raise that to the 23rd power, which is not at all what we want. We want to divide by this enormous quantity. So we should end up with an answer that's really small. The other option, which I don't know why, but people just don't always love it, when you're entering this in your calculator, obviously you can do 6.022 times 10, then hit that caret key, 23. But that's where you might find yourself needing to use the parentheses so that you're recognizing it as one quantity. Or use the exponent key. You could use 6.022, and then it's like a second function, but there's like this little EE key, and then you just type in 23. When you use that exponent key, like the EE key, you don't have to say times 10 EE 23. That key is specifically meant to be used for scientific notation. So all you have to do is say 6.022, and then EE kind of means like times 10 to the what? And then you just tell it the exponent. Same thing like when you get an answer. If you get an answer that's like 3.29, and then your calculator says E negative 19th, well, we want to get used to writing it as like the proper number. The E is calculator symbols. We want to write it like that, times 10 to the negative 19th power. Alrighty. Then in part B, calculate the frequency. Well, now I can use that equation. E equals HV. H is Planck's constant. It's in the packet. And I know E, energy. Now, we also kind of mentioned earlier that when you use this equation, E is energy of a photon. Of a photon. That's only energy of one photon. So I wouldn't be able to just jump to part B using 198. Because that Planck's constant needs to reference the correct energy value, and it needs to be per photon. But now that I've corrected for that, I've got it in joules. which again, it has to be in joules because Planck's constant is in joules. So these units need to jive, and then it's per photon. Now it's just plug and chug. So when you do the math and you think about your units, the joules are going to cancel when I divide. And so my final answer is in units of like waves per second, cycles per second. You could say 1 over seconds or seconds to the negative first. It's okay if you do like 1 over SEC. Any of that is totally fine for seconds. 1 over seconds. Okay, now we've got the frequency. And so the last part of this is to solve for the wavelength. Using the wavelength information provided below, what is the color of light? Justify with the calculation. Okay, so now I'm going to use the equation speed of light equals frequency times wavelength. The speed of light's in my packet. I've got the I've got the frequency. I can solve for the wavelength. And again, if you're having troubles getting this answer, 6.04 times 10 to the negative 7th, maybe try putting these guys in parentheses, like these big guys, especially if you're using the times 10 caret 14 or whatever. We just want to recognize that we're dividing these two quantities. Cool. Then sometimes that answer will be fine, but in this case, the chart gave us wavelengths in units of nanometers. And so I'm going to need to convert my wavelength, which will be in meters, because my speed of light is in meters. So these units also need to jive. And then this might be a conversion factor that you just want to write in the packet. It's not in there, and they're not going to give it to you on the AP test. But the more you look at it, the more you'll hopefully kind of remember. There's 10 to the 9th nanometers in 1 meter. Nanometers are crazy, crazy, crazy tiny, little fractions of a meter. So it takes 10 to the 9th nanometers to make 1 meter. Then I get an answer that looks a little bit more reasonable when I go back to this table. About 604 nanometers, which should put me somewhere in the visible orange light portion of the spectrum. And then that's it. So there's the two equations and how we would use them, and maybe little things that we have to watch out for, which is often units. I need to be able to convert like between kilojoules and joules, joules per photon, or is it joules per mole of photon? And then here I need to be able to convert between meters and nanometers. Now here's one progression through these equations, but you could also do this backwards. Like if they gave you a wavelength, maybe they would say like how much energy is being emitted from this photon or whatever. Where if I had a wavelength, I could go backwards and solve it for frequency. If I had a frequency, I could go backwards. I could plug it into this Planck's constant equation. I could go backwards and solve for E energy. And then that would be energy of a photon. And then maybe I need like energy of a mole of photons or something like that. So I could go through this progression in either direction. Given energy, go figure out the wavelength. What type of waves is it? Or if I were given a wavelength, I could go backwards and figure out the energy change.